Economics, Standard 12, Topic Unit 4, the Accelerator Principle. The systematic development of simple accelerator model was made by J.M. Clark in 1917. J.M. Clark in 1917. Later, it was just developed by Hicks, Samuelson and Harrod in relationship with based on business cycle. Now, what is accelerator? The accelerator coefficient is the ratio between induced investment and in initial change in consumption. Suppose, assuming the expenditure of rupees 50 crores in consumption goods industries lead to an investment of rupees 100 crores, the accelerator is equal to. So, the formula for the accelerator is equal to, that is change in investment divided by change in consumption. That's what the definition that says. The coefficient is the ratio between induced investment and initial change in consumption. So, assuming once again, if an industry, that is the expenditure of rupees 50 crores on consumption goods of industries lead to an investment of rupees 100 crores, then the accelerator is equal to 100 divided by 50 equal to 2. Now you can just understand the definition of the accelerator clearly. There are assumptions of an accelerator. So, absence of excess capacity in consumer goods industries. So, the first point is absence of excess capacity in consumer goods industries. Second, constant capital and output ratio. The presence of constant capital and output ratio. Capital and output ratio should be constant. Third, increase in demand is assumed to be permanent. So, that should be an increased demand always. Then fourth, supply of funds and that is other inputs should be quite elastic in nature. Supply of funds and other inputs should be quite elastic. And fifth point is capital goods are perfectly divisible in any required ratio. So, capital goods should be divisible at any required size. That's what that we have to remember. Okay, now how does the accelerator operate? Let us suppose the goods that what we require. So, goods to be required 1000. So, if just I take for example goods to be required 1000. So equal to 1000 and of course what would have been the machines, that is, so the machines required will be 100, just assumption only, so 100. So every year, that is, the machine has got life, so that is working life expectancy. So, if working life of a machine is just 10 years, so every year 10 machines to be replaced in order to maintain the constant flow of 1000 consumer goods. Suppose that demand for consumer goods rise by 10% for, that is, from 1000 to 1100. So, goods to be required 1000, machines required 100, and every year 10 machines are replaced. Suppose the 1000, that is 10% rise for the goods to be required means then 1000 plus 10%, that is 100, equal to 1100. So automatically what would also increase, that is the rate of investment also will be increasing. So the machines also will be increased. So total demand for machine increases 10 plus 10. So total demand for machines, total demand for machines increases. So that is 10 already plus 10. So 10 plus 10. So the first 10 is just for replacement. The other 10 is that is increasing for meeting increased demand. So there is an increased demand, the same, that is here 10 more machines are also just increased. So remember, 10% increase in demand for consumer goods causes 100% increase in demand for machines. So 10% of increase in demand for consumer goods results in 100% increase in demand for machines. So that is from 10 to 20. So even a mild change in demand for consumer goods, a mild change in demand for consumer goods will lead to wide change in investment. And this can be just seen in the diagram. So x-axis and y-axis we can just continue. So x-axis horizontal axis, and in x-axis we just draw the horizontal line x-axis income and vertical line y-axis savings and investment. See, I have just marked here 0 from y1, y2 and y3 in income x-axis, and in savings and investment vertical line y-axis I have just written here I2, I3 and I4, and SS is savings curve. So SS is saving curve and II is investment curve. And just see here, at point equilibrium 1 you find 0 y1 and 0 I2. So 0 y1 is equal in the equilibrium point 1, and so we can just find out that 0 y1 is equilibrium at point E1, that is. So saving I are equal to, that is what we have, say 0 I2. So saving y1 is equal to 0 I2 in equilibrium 1. Okay. Now equilibrium point E3, just to see here, there is no equilibrium point E2 where you don't find this investment curve. So investment curve just comes below the equilibrium 2, and but here just the investment curve just starts from investment 2 and then gives the equilibrium only in equilibrium point 3. So in equilibrium point 3 you find that is the income is from y1 to y3. So y1 to y3. The difference, that is y1, according to the multiplier effect, y1 and y2 is that multiplier effect. Then y2 to y3 is actually accelerator effect. So multiplier effect is it increase investment by I2 and I4. So I2 to I4, then what would have been there? Increase income will be by y1 to y3. So therefore, increase in income by y1 to y2 will be the multiplier effect. But in the accelerator effect, it is assumed that exogenous investment is only by, that is I2 to I3. So I2 to I3. So I3 to I4 is actually an increase income by, that is y2 to y3. So income, actually increase in income by y2, y3 is accelerator effect. This can be clearly seen in this diagram.